has decimals? Think about this question during the lesson. Juanita is reporting on pitching statistics. Pedro threw 80 pitches in all. He threw 10 splitters, 18 sliders, and 52 fastballs. Pedro's fastball statistic is 52/80ths. How can Juanita write the fastball statistic in decimal form? How can you write a rational number as a decimal? Let's use a bar diagram to show how the quantities are related. In what form is the pitching data represented?
Select your answer.
The statistics on the baseball card are displayed in bar graph form with the first 3 bars representing the number of each type of pitch. Our bar chart only needs to compare the number of fastballs to the total number of pitches. The chart shows that Pedro made 80 pitches in all. 52 of those pitches were fastballs. That means 52/80ths of the pitches were fastballs. Our next step is to convert the fraction to decimal form. Why should Juanita use a decimal for the fastball statistics in her report? Statistics are often given as decimals. It's easier to understand a decimal than a fraction with a denominator of 80. Also, using decimals make it easier to compare statistics with other pitchers, games, or types of pitches. We need to divide to convert the rational number, 52/80ths, to a terminating decimal. A terminating decimal is a decimal that ends in 0. 80 goes into 52 0 times, so we place the decimal point in the quotient and annex zeros as we need them to divide. 80 goes into 520 6 times. 6 times 80 is 480. Subtract from 520 and you get 40. Annex a 0, leaving a remainder of 400. 400 divided by 80 is 5. 5 times 80 is 400. Our remainder is 0. Because the remainder is 0, the decimal 65/100ths is a terminating decimal. Juanita can write the decimal 65/100ths. Are 65/100ths, 650,000ths, and 6,510,000ths equivalent numbers? Yes, they are equivalent numbers. If we continue the long division, every digit after 0.65 is 0. Now you know how to write a rational number in the form of a decimal.
In the next several games, the pitcher threw a total of 384 pitches and used a fastball 240 times. What decimal should Juanita use to update her report?
So we're going to rewrite the fraction now as 240 over 384. And then we're going to divide 384 into 240. 340 cannot go into this at all. So we need to add a decimal and a 0. And let me just choose a different color. Oh, it erased all my stuff. 384 into 240. So we have a decimal and a 0. So now 384 can go into 12,400, I think 6 times. So that is going to be 2,300. That's going to be 0, 0, 1. And so add another 0, bring it down. 384 into 1,000. Could go into it twice. 384 times 2 is 768. And then minus 1,000 is 232. And add another 0. So 2,320. 384 being 5. 384 times 5 is 19,020. And then just for space and everything, I think we could stop here at the 10,000th place. So the new decimal would be 0 and 625 hundredths. Make the decimal bigger.
A class votes on whether to change their school mascot. How can you express the number of students in favor of a new mascot in decimal form?
Divide to write 5/8 in a decimal form. And so this is a repeating decimal because the 7 will continue to repeat as you continue to divide. So the decimal form of 5/18 is 0 and 277 thousandths or 27 hundredths. Repeating with that line above it. The line above it is what indicates that that digit is the one that repeats.
What is the decimal form of 100 thirds, 100 fifths, and 100 sixths? Determine whether each decimal repeats or terminates.
So you will need to divide each of these decimals. Fractions. I can't speak. Fractions to create the decimals. So we have 3 into 100, and that would be 30. Well, 3, 9, 1, 10, another 3, 9, 1, and then you have to add a decimal. And then 3 goes in 10 again. So it'll be 33 and 3/10, and this will continue. As you can see, the pattern is the 10 going down as we divide. So this one, 100 over 3, will be the 33 and 3/10. So that's repeating. All right, now I'm going to do 100 over 5. So we have 100, 5. 5 goes into 10 twice. Bring down a 0. 5 goes into 0 0 times. Add a 0, 0. 5 goes, we have to add a decimal there. Forgot to do that. 5 goes into 0 0 times and 0, and this will just continue to repeat 0 0 0 0. So, or not really, it just ends at 0. So it's just 20. So this actually will be a terminating because it goes into it equally. So that terminates 100 over 5. Last is 100 over 6. And it goes into it once. Equals 4. 0. 6 times 6 times 6 is 36. Equals 4. Add a 0. 6 goes into 40. And then this will keep going. So that'll be repeating. So this is 16 and 6 tenths repeating. So this fraction is also repeating.
Write each decimal as a mixed number or fraction. Part A, -6 and 38 hundredths. Part B, 1 and 55 hundredths. Part C, 425 thousandths.
So let's look at A. A, they wrote it as a fraction, and it's a mixed number, and they just took the 38, put over 100 because the 8 is in the hundredths place. So that's what it'll be over as a denominator, 38 over 100, and we simplified it to get -619 over 50. For B, you have 1 and 55 hundredths. Again, you put it over the 100, 55, and then they simplified it. For C, they 425,000, so you put it over 1,000 and simplify it. 17 over 40. So we need to write these decimals as a mixed number or fraction. So let's do that. So this will be 8 as the whole number, 26 hundredths. And then we simplify. So that would be, let's see, 2 can go into both. So we'll have 8 and then 14, 13. 13 over 50. And for B, we have 675 thousandths. Wait, yeah, thousandths. So that goes over 1,000. And then you simplify. Off my head, 5 is a common factor, but I think there's a bigger common factor. The bigger common factor would be 25. So 675 divided by 25 is 27. And then 1,000 divided by 25 is 40. And this would be negative because we started with a negative.